Hello everyone, this is Itikur Rahman and welcome to the second lecture of the fourth week. So let's start. By the end of this lecture, you guys will know about adder, half adder as well as full adder. So let's start with the outline. This slide represents what we are gonna learn from this lecture. So such as we can learn from this lecture adder, classification of adder, overview of carry, overview of half adder as well as its block diagram, half adder logic circuit, truth table and Boolean expression of the output section of half adder, and so on. So let's start with the overview of adder. An adder is a digital logic circuit in electronics that implements addition of numbers. In many computers and other types of processors, adders are used to calculate addresses. Similar operations and table indices in the arithmetic logic unit, which is in short ALU, and also in their I repeat again, and also in other parts of the processors. These can be built for many numerical representations like XS3 or binary coded decimal, which is in short BCD. From this slide we may learn classification of adders. So let's start. Adders are classified into two types, such as one is half adder and another one is full adder. Let's start with the concept of half adder. The half adder circuit has two inputs. One is A and another one is B, which add two input digits and generate a carry and sum. And figure 1 represent the concept of half adder. We already know just few seconds ago that half adder has two inputs. One is A and another one is B, and which produces two parameters. One is sum and another one is carry. Next, the full adder circuit has three inputs, such as A, B and C in. C in represents carry in, which add the three input numbers and generate a carry and sum. We already know two types of adders. One is half adder and second one is full adder. Half adder has two input. On the other hand, full adder has three inputs. So I hope you guys just familiar with half adder as well as full adder and the difference between these two things. So let's move into the next slide. Now we need to know carry. What is carry? So let's start. When adding binary numbers, a carry out is generated when the sum equals or is greater. I repeat again. Sum equals or is greater than 2 and 1 plus 1, and this becomes a carry bit. For any subsequent addition being passed over to the next column for addition, and so on. And figure 3 represent the concept of carry. Forget about this figure, just think about in this way. You need to add 6 and 7. What you will get? 13, right? 6 and 7, if we add 6 and 7 we get 13, and 3 is on the 6 and 7 column and 1 on the immediate left column, which is 1 in here. 1 is the carry. I hope you understand the concept of carry. So let's start. I repeat again. So let's move into the next slide. And this slide represents some of the examples of carry for your clear understand. I hope you will be understand about carry. So let's move into the next slide. From this slide we may know HalfAdder as well as the block diagram of HalfAdder. So let's start. The HalfAdder adds two binary digits called as oscent and addend and produces two outputs as sum and carry. We already know this from the previous slide. XOR is applied to both inputs to produce sum, and AND gate is applied to both inputs to produce carry. Remember these things. I repeat it again. XOR is applied to both inputs to produce sum, and AND gate is applied to produce, sorry, I repeat again, AND gate is applied to both inputs to produce carry. And figure 5 represents the block diagram of HalfAdder. And we have already known that HalfAdder has two inputs, which is symbolized by capital A and capital B, which is in the left side of the block diagram, and produce two parameters. One is sum and another one is carry, or you can say carry out, which is in the right side of the block diagram. So let's start with the so let's move into the next slide. From this slide we may learn the circuit diagram of HalfAdder. In previous slide we have learned the block diagram of HalfAdder, and from this slide we may learn the circuit of HalfAdder. So let's start. A HalfAdder is a logical circuit that performs an addition operation on two binary digits. The HalfAdder produces a sum and a carry value, which are both binary digits. And we have already know that from the previous slide, which is XOR is applied both in the inputs and produces sum. And XOR is applied means XOR gate is applied. Okay. Then AND gate is applied into the both inputs, which is A and B, which is produces carry. So I hope you guys are understand now how can we draw this circuit. So there is no problem. So let's move into the next slide. From this slide we may learn truth table of the HalfAdder circuit. So as we already know, HalfAdder has two input, and since HalfAdder has two input, then we can assign two binary numbers. One is 0 and another one is 1. And if we combine these two binary numbers, then we get four combinations such as 0 0, 0 1, 1 0 and 1 1. And in output section, since we get two types of output, one is sum and another one is carry, in the sum column, or you can say when we get the value 1 in sum or on sum, when one of the input is 0 and another one is 1, in that case only we get 1 in the sum section. And the vice versa means one of the input is 1 and another one is 0, in that case also we get 1. Rest of the cases we get 0. In the carry section we just get 1 only in one condition, when the two inputs both the two inputs are 1, in that case we get carry 1. Well, from the truth table of the HalfAdder we can see that the sum output is the result of the exclusive OR gate. We have already know this thing. And the carry out is the result of the AND gate. So let's move into the next slide. From this slide, we may learn the Boolean expression of the output of half-adder, which is for the sum bit we get A XOR B, and for the carry bit we get A and B. Just you guys are comparing this expression with the previous slide truth table. I hope there will be no problem for your understanding. So let's start. So let's move into the next slide. From this slide, we may learn about full adder as well as the block diagram of full adder. So let's start with the overview of full adder. Full adder is difficult to implement than a half adder. The main difference between the full adder and the previous half adder is that a full adder has 3 inputs. On the other hand, half adder has only 2 inputs. The same 2 single bit data inputs A and B as before, plus an additional carry in, which is in short Cin, input to receive the carry from the previous stage. Well, figure 8 represents the block diagram of full adder, and in the left side, if you see, then you can find there are 3 inputs, which is symbolized A, B and C in respectively. And in the right side of the block diagram, you can find the 2 output. One is sum and another one is carry out, and which is also represented or symbolized by capital S as well as C out respectively. So let's move into the next slide. From this slide, you may learn the I repeat again, from this slide you may learn the logic diagram of full adder. And if you see on the figure 9, you may find there is 2 half adder back to back and also connected with a I repeat again, and also connected with the OR gate. So from this figure, one thing is clear: full adder circuit, full adder logic circuit has to be drawn by the 2 half adder circuit. Okay, as the full adder circuit above is basically 2 half adders connected together, the truth table for the full adder includes an additional column to take into account the carry in, which is in short Cin input, as well as the summed up S and as the summed output S and the carry out C out bit. From this slide, we may learn the circuit of full adder. So let's start. Figure 10 represents the full adder circuit. We already know, or we have already know and learned that full adder has 3 input, which is symbolized by A, B and C in. And from the output section of full adder circuit, we get 2 parameters. One is sum and another one is carry out. Full adder is a logical circuit that performs an addition operation on 3 binary digits, and just like the half adder, it also generates a carry out to the next addition column. Then a carry in is a possible carry from the less significant digit, while a carry out represents the carry out represents a carry to while a carry out represents a carry to a more significant digit. From this slide, you may learn the truth table of full adder circuit, and from the truth table you may notice that there are 3 inputs and 2 outputs. 3 inputs are symbolized A, B and C in respectively, and the outputs are symbolized. One is sum, which is in short we can write capital S, and another one is carry out, which is in short we can write C out. And since there are 3 inputs for full adder, so we may assign 3 binary numbers, and which if we combine the 3 binary numbers, then we get 2 to the power 3 8 combination, and you see there are 8 combination of 3 binary numbers, and in the sum section there are 4 1, and in the carry section there are also 4 1, or you can say we get only 1 when the condition we only we only get 1 on the 4 condition in the both output cases. So let's move into the next slide. From this slide we may learn the Boolean expression of the output section of full adder. For the sum bit we can get A XOR B as well as XOR C in, and for the carry out we get A and B or C in and inside of the parenthesis A or B. Remember these things. Now we need to have a look about the advantages of adders, such as HalfAdder's design is very simple. It is the basic building block for single bit addition. Next one, just with an inverter gate, HalfAdders can be converted to half subtractors. Third one, full swing output can be obtained with full adders. Fourth one, power consumption is low. Fifth one is speed is high. Sixth one is robustness to supply voltage scaling. Now, since we already learn about advantages, we need to learn what is the disadvantages, or what are the disadvantages of this parameter, or you can say the adders. So let's start with the number 1. It does not incorporate inside of the parenthesis or take care of previous carry for addition. Hence it is not suitable for cascading for multi-bit addition. Next one, to get rid of this problem, full adders are required which add 3 1-bit. Last one, when full adders are used in a chain structure such as a ripple adder, the output drive capability is reduced. Now time to learn some application of adders. Let's start. A full adders circuit can be used as a part of many other larger circuits like ripple carry adder, which adds n bits simultaneously. Next one, the dedicated multiplication circuit uses full adders circuit to perform carry out multiplication. Next one, full adders are used in arithmetic logic unit. Next one, in order to generate memory addresses inside a computer and to make the program counter point to next instruction, the arithmetic logic unit makes use of full adders. Last one, full adders are part of graphics processing unit, which is in short GPU, for graphics related applications. In the next lecture you guys will learn subtractor, half subtractor and full subtractor. Thanks for this lecture, and thank you guys, and I repeat again, thanks for this lecture, and thank you for your attention guys. See you guys in the next lecture. Till then, thank you.